All right, so good morning, shell programming. So regarding which room we do this in, is there anyone who will not be having a laptop with them as they come to class each day? All right. If everyone's going to have a laptop, then I'm fine just hanging out in this room. I need to check with the front office. I guess we'll find out sometime over the next 3 hours whether another class is scheduled to meet in here. Anyway, I'll work that out. Let's assume that it's in here, I guess. I'll just post something to the course shell. Actually, I'll do it either way. So look to the course shell before tomorrow on where we meet. It'll either be here or that other room. And for those who aren't here, that we are currently in room 254 because 244 was locked. So I guess that brings up the very first topic, which is there's a handful of you who had emailed me prior to the start of the course saying I already have this obligation, it's going to keep me out this day or these pair of days, and is that going to be an issue? The short answer is no, it's not an issue. So if there's a day you can't make it, I'm not taking roll, I'm not grading you on whether you're sitting in front of me. However, there is in general a fair amount of teamwork, and there's a fair amount of work that needs to be done, and you can get behind very, very quickly. If you get behind, it's going to be real difficult to catch up. So you're all grown-up adults, I'll leave you to your own devices. But definitely if you can ensure you make it here, that's going to be the best. Of course, you know the format. It's for 6 weeks, 3 hours a day, 4 days a week. I do not like to lecture. I am not going to lecture at you 3 hours a day, 4 days a week. I imagine today is going to be one of the longer days, and I think it'll probably go 90 minutes. And so what I like the bulk of these periods to be is working on stuff, right? So that's why I'm asking about the laptops, is that need you to be doing some shell programming. And they're going to be both assignments and class things, larger projects. How many? I don't know, 7 to 10 assignments, 7 or 8 projects, something like that. A few in-class things here or there. I didn't do this last time. I'm thinking of formalizing this a bit more, which is kind of, I don't know if I want to call them code reviews or just looking at everyone's code. I think what I want to do is when you submit stuff, it is tied to your ID when it gets downloaded, so I can identify your work based on that. What I would like you to do is not put any identifying information in the work you submit, so that what I can do is I can just wholesale bring up code that you all have written, and we talk about it, right? We'll compare 3 to 5 to 8 different solutions to a particular problem. We'll look at the different ways of doing it and talk about, this way's good, this way could have been done better, that kind of thing. So that'll make it easier if you just simply don't put your name or anything in the comments of the code you write. Regarding, let's see, regarding what you do this on, so obviously the program here at Chico State is Linux. Shell programming is obviously intended to be Linux versus, say, PowerShell or something which would be Windows. It would be best if you are working on Linux, and I know many of you have OS X boxes. I myself am running a Mac right here. If you are able to run in Linux, that would be better, simply because some of the shell tools we'll be looking at do have some quirky differences between Linux and the Mac. If you have Homebrew on the Mac, I think that mitigates it some. So you can try going on the Mac, but I'd recommend doing Linux as far. Okay, what does that look like? I have, if you've taken a course with me before, in the recent past, say last semester, I have put into place some Vagrant boxes. If you're unfamiliar with Vagrant, you're probably familiar with VirtualBox, which is just virtual machine software. And Vagrant is a nice command line interface to virtual machines. So you can just basically on the command line, you can download a virtual machine that I've prepared, get it installed, up and running, and shell into it. Okay. I would wish I had something here. Maybe I can, let me go, I'm going to do a little of the one piece of course prep that I meant to do that I totally spaced on was this Vagrant thing. So let me pull, I've got a little write-up. Let's see. Let's go into this course. And pre-course setup, what does that look like? Yeah, all right. So let me take pre-course setup. No, let me take this thing. That's going to make me, should be able to copy that. It won't let me copy as the link, so let me do this. Copy into that. Yeah, I'll have to put it there temporarily. Create. Yeah, I like that better. Okay. So, here's this Vagrant stuff. This basically is just a write-up telling you how to get Vagrant up and going. And it says, so I've got a virtual machine up there on the Vagrant database repository, a machine for 540, and actually it'd work perfect for this shell course, so that would be fine. Anyway, I'll let you toy with that and let me know if you have any issues working with that. The daily diatribe. So if you haven't taken a course with me before, I record all my lectures. I'm recording right now, so you'll be able to pull that. Those recordings are only partially useful since it's going to be a workshop heavy class. Obviously I'm not going to record you all working away on stuff, but to the extent I'm talking like right now, that stuff will be recorded for you to refer back to, or if you are forced to miss a day, can get it from there. Syllabus. Oh, the daily diatribe. And so each day I also post notes of what we did and any files that I generated while I'm talking. So that'll should be front and center whenever you get into this course shell. Projects and assignments, we'll be looking at that as we get into them. Let's look at this syllabus. Alright, let's see what this says. There was a period of time where the write-up for this course talked about Perl. This write-up may not follow the catalog exactly. csci344 Chico State. Let's see if it got updated. That does not look updated. All right, ignore that. So we'll be doing Python. The way the course will work is there will be about 3 weeks where we're doing shell type stuff, and then 3 weeks where we're doing Python. My objective for the course is that after you're done with the course, regarding Python, is that you have some sort of task to do. You're pretty familiar with C++, so that's kind of the go-to language for things. My hope is that when you're presented with any task, you will be equally likely to choose Python or just some shell scripting as you would C++, meaning that you have a real fluency and a comfort with it, right? There are definitely things where you'd rather use shell programming, and definitely things where you'd rather use Python than C++. Yeah?
You expect any Python knowledge?
I expect 0 knowledge. So if you've got some knowledge, then you're ahead of the game. Shell programming, so basically all a shell program is a shell script is anything you would type on the command prompt is something that you can put into a file and run. It's that simple. The shell itself, and we're definitely going to dig a lot deeper in this, but the shell itself has some built-in constructs that would be familiar to you from other programming languages, an if statement, a looping construct, variables, right? All these things are built into the shell itself. But there's a huge number of things that aren't built into the shell that are external commands. The obvious ones are things like ls, cat, sort. There are ones that you probably have been less likely to use, such as sed and awk. I sat in on a class a couple years ago, and the instructor was, I think they're discussing awk, and they said that awk was this old, outdated thing, and really the reason we're going to look at it a little bit is there's a lot of existing code out there. Now that may be an argument for learning COBOL, but awk has been around a long time, and it's still there because it is still absolutely very, very good at what it does. Sometimes it is the best tool for the job. That goes for sed, that goes for everything else in Linux. You could argue that all Linux is it's just based on Unix, and that's an old dinosaur, right? Who would ever use that stuff? The reason the stuff's there is because it's still useful. As far as my personal experience using shell scripting is, I would say that shell scripting is probably the single greatest thing that has been that thread throughout my career. Of course, I spent well over a decade in industry before switching careers and going into academia. There are always times where you needed to do shell programming, a lot of times to glue together workflows or just to change data. You got it in some crappy Excel CSV format, and you've got to spin it and massage it and get it into a different format to feed it into this tool. And you have 5 or 6 steps along the way, and the shell programming just makes that wonderfully easy to do. So anyway, what are the objectives? That stuff. Regular expressions. The part of the problem with this course is there's definitely overlap with other courses. 444 comes to mind. I'm not sure 444. Has anyone taken 444 here? I think I was probably the last one to teach it. So if you'd taken 444 from me, then there would have been some overlap with the shell scripting portion, because you can't really do system administration without doing a lot of shell scripting.
What does you use a lot of regular expressions?
In web development, you use a lot of regular expressions.
Yeah, because
Yeah.
the way Dixon teaches it, he uses Django still. And so to do having, you use regular expressions.
Okay. Well, good. So some of this stuff you would have seen elsewhere. Definitely some of it with me. Some of the stuff I'm going to talk about today would be stuff that I would also have talked about in systems programming, actually. But we'll be looking at it in a lot more detail. Just ignore that. 251, 254. All right. My office, if you're not familiar with where my office is, if you walk straight out and you hit the wall, you've almost hit my door. Of course, there is no textbook. There are Linux tools / shell programming / Python books you can get. encourage you to get them. You know, the web was invented by programmers, and if you need programming references, they're free for the taking. So I don't see any reason to charge you for a textbook. I'm not one inclined to follow one anyway. The format, I already talked about that. Hands-on, hands-on, hands-on. It'll just be projects and assignments. I don't grade on a curve. Really, based on the last time I taught this, and it was certainly my intuition last time, is the grades are really polarized. If you're here, you're coming to class, you're doing the work, it's hard not to get an A. Okay? The minute you start dropping things, it gets really hard, well, impossible to get caught up, and so you end up on the failing end of the spectrum. So that's just kind of the way it works. It's hard to hit that middle ground of a C, because either you can do this stuff or you can't. So one of the things that I'm big on is the ability to work exclusively through an alt-text interface. I will absolutely concede that there are a huge number of jobs out there where you're going to be working with some integrated development environment all day long, and you're going to be clicking your mouse and connecting to web pages and so on and so forth. There's also a large part of the programming community where this is all you got, and you need to know how to get into other machines, navigate around, bring up editors, and do entire things just working at a command prompt. So that's kind of where I'm at, is I want you to be more comfortable with that. Regarding editors, I definitely have a bias towards Vim. I'm going to force that down your throat now. I apologize. I know some of you have not come into the light and have been reluctant to embrace it. Now's your big chance. So I will be the first to concede I have a bias. Will be the first to concede it's a bitch to learn. But there's no doubt you hit a certain point of critical mass and everything, all the light bulbs come on and you go, yes, I want to use it.
So you're the opposite of Dixon.
Yeah, he doesn't. So Dixon doesn't care for my evangelizing, so I also do. I'm less onerous about it, but I obviously push it on the 111 students, and the reason the 111 students use it is they don't know any better. Right? And so one of my big things is the navigation for Vim is all on the home row of the right hand. The very, very basic, the up, down, left, right, and so I immediately want to discourage. Absolutely, one of the reasons I'm into Vim is that you don't take your hand off the keyboard and get a mouse to move it, but you also don't take your hand off the keyboard and go to the arrow keys, right? If you spend just a few days with Vim, using H, J, K, and L becomes natural. Everyone in 111 who does it, by the end of the semester, they're going into Microsoft Word and they're typing H's and J's, trying to move around. It's easy. Once you break yourself of the arrow habit, then you never go back. So what I do is I turn off the arrow keys, and that pisses off Brian Dixon because he goes to the arrow keys and they don't work because I've turned them off in 111, and the students are still using the same configuration files.
Do you have those configuration files for us to use?
Absolutely. Absolutely.
I have a picture of it.
Vagrant box.
Are they?
Oh yeah. If you get my Vagrant box, I pushed all of my biases on you already. So another reason for set all of that aside. Another reason for using Vim is that you can integrate them into shell scripts, meaning that any command that you can do in Vim, you can also script. And so there are certain times where you have to do some kind of funky edits to a file, but not just a file. The reason you're putting in a script is there are 1,000 files you got to do it to. So you're able to take the Vim commands, put them into a script, and then basically you're just able to fire that through 1,000 files, and it'll kind of run Vim under the hood and make that happen. So that's another side motivation. It does have a real tie to shell programming. SSH tunneling, I'm not Sure, I must have cribbed this list partially from something else I was doing. SSH tunneling is not like a big multi-week topic that's going to be part of one day, but I had something to make a bullet point. So you'll learn some SSH tunneling, SSH generally, terminal multiplexing. That's this, taking a terminal screen and having multiple panes, multiple windows, configuring this, customizing it, using it. Of course, we'll be doing Python in the second half of the course, regexes, we've talked about that. All right, and then we've got boilerplate on cheating. I'm really not sure how you're going to cheat in this course. There's not a lot that we're doing in here that you're going to find on the web. All right. Now I'm going to pause for a minute, and I'm going to make a confession that I've never made before. Okay. My weak point as a human being is that I am literally on the bottom end of the spectrum of someone who can put names to faces. I've had people who've had 4 classes with me. I know them very well. I know their work very well, and never has their name and face connected the same. It's just, I'm just terrible at it. So I have, I decided partway through last semester that I'm going to start committing myself to, by golly, making sure I look at your face and I know your name. Okay? It may take me 5.5 weeks, but I'm going to try. So I know just a couple of your names in here. I know a few more of your faces. So first, the apology. It's nothing personal. If I don't know your name, it's on me. Okay? I do want to learn your name. So whenever we talk, I'm going to pause and I'm going to try and guess your name, and then you're going to correct me. And we're going to keep playing this stupid game until it gets into my thick skull what your name is. Okay? So I just want to take a moment and do that. Griff, Jeff, congratulations. Your name, say?
Ryan.
Ryan. All right, Ryan. Sean, Ryan. You have to always dress exactly the same way, okay? Because Ryan's wearing the gray coat and the Giants baseball hat. Sean, don't shave. All right. Adam. All right. Ryan, Sean, Adam. Griff, Jeff. In the back, Quentin has curly hair. Quentin. All right. Don't shave your head. Okay. Quentin, Ryan, Sean, Adam, Quentin, Cody. Okay. Cody's got the big sticker-born thing. Always hold that when I look at you. You see, I'm already forgetting them. Ryan, Sean, Adam, Jeff, Griff, Quentin. Oh, fuck. Cody, God, you see, Cody. Yeah, I need to get better at this, so I'm going to torture myself. Quentin, Cody. August. Okay. August Alexander. So you didn't know the name. August. Okay. Quentin, Cody, August. Quentin, Cody, August. Quentin, Cody. All right. Yusef. All right, Yusef. Yusef wears his hat backwards. Ryan wears his hat forwards. All right. So you two are gonna switch and really screw me up. All right. Ivan?
Yeah.
Ivan. All right, Ivan.
Colin.
Connor.
Yeah.
Connor. All right. What's your last name? Mulligan?
Yeah.
Okay, Connor Mulligan. All right. Tell me again.
Ivan.
Yusef, Ivan, Quentin, Cody, August, Yusuf. Ivan.
I'm
Yeah,
terrible.
Connor.
I'll be talking all semester, so you'll learn my name real quick.
Okay, Ivan. Connor?
Yeah.
And
Kyle.
Kyle.
Last name Kirk, like the captain.
Kyle Kirk. Okay. All right. I'm a little bit hot and uncomfortable. That was difficult for me, but I'll keep at it. All right, thank you. So I appreciate you bearing with me with that. So I guess I'm ready to dive in. Any questions before I do? Okay, so let's go ahead and talk about this a little bit. Vagrant, let me get my Vagrant box going here. I should have done this while I was doing the names.
And then after class, would you mind uploading your Vim configuration file? Yeah, that'd be awesome.
I'm sure it's still on the 111.
Okay.
So if you get the Vagrant box going, it's in that.
Yeah, I'm using my base Linux shell. I'm not planning on doing the Vagrant box.
Okay, so let me do this. I can go, while this is uploading, I can say secure copy, K Gibson at Jaguar, bin helper to, let me make a directory. This is week 1, day 1. And I want to copy that to here. Let's look at what's in this file. All right, so maybe you don't want all this stuff. Let me create move help or copy. So this is the entire helper script for my 111 students. Let me do helper vim only. Oops. And let me go ahead and just get rid of all this. And it'll stop there. So if you run this, it will append these commands to your vimrc. These are comments. This is going to disable all the arrow keys. That's going to turn on line numbering that we have on the left side. And it'll get indenting going. And it will it'll set your indentation to 2 spaces and expand tabs, which, because having a combination of tabs and spaces in Python is a little bit deadly.
Yeah.
So if you run helper vim only, that will append the correct stuff to your vimrc. And of course that'll be posted with today's notes. All right. So let's ask the easy is this done? Yes it is. Get into my virtual machine. All right. How can I see what processes are running for me? PS. So there are 2 that I have running here. One is PS itself. And the other is bash. So bash is the shell. What exactly is the shell?
Command line that you're working on right now.
Okay. Where did it come from? Let me ask a different question. Where did ls come from? Huh? Yeah, it's in a file. Where can I find it?
The man pages.
That's where I can find. That's where I can find the documentation on it, which we'll talk about more in just a little bit. If there's a command called which will tell me where in the file system ls is. So I can do an ls-l on user bin ls. So I guess you're probably apprehensive to answer because you're not sure what I'm asking, but that's fine. Just what is ls? Where did it come from? Why is there not something in there called QS? Why is it called LS? Why? Who put it there? Who named it? Who made it? How was it made? Sort. Oops. It's another one. Where do these come from? What are they?
The person who coded up bash.
So I think the thing I want to hang my hat on is the person who coded up. So these are just programs someone wrote. They coded them up. They have a main function. You all have taken enough C++ to know argv and argc, right? So they're probably processing those. Like ls is processing that is an argument, and that is an argument. It's just a program someone wrote. All right, so that's all the bash shell is. Oops. What does this look like? That's confusing, isn't it? That's it. It's just a program someone wrote, yeah? If it was written in C++, it'd be a bunch of C in and C out statements. After they do a get line, assuming it was C++ and it was written this way on line 8, there would be, I don't know, a switch statement, a bunch of if statements. There'd be some sort of decisions made to look at what it is you typed in and deciding what to do. And then once it's done doing what it needs to do, it loops back up and it hits line 6 again. So if it's a program that someone wrote that I can run, can I run it? I can run ls. Can I run bash?
Yeah.
Let's try it. How do you know it's running?
Yeah.
Yeah, now there are 2 of them. All right. So yeah, this is the one we just started running. There are. And if I type bash again, there are 3.
How do you stop?
Why? When does bash get run? This one right here. That one.
The moment you start up
The moment you start it up. When do you start it up?
Terminal window.
terminal window.
If you exit, it'll close the window.
What about I'm sorry, I'm in, let me just bring this up for just a moment. Assuming FDSA was a user on Jaguar and I entered in the password correctly, what would I get after I authenticated correctly? Bash would run, right? So the login program does the authentication, and once you're authenticated, executes the user's command interpreter. Why bash? It's not the only shell out there. SH, the Bourne shell would have been the original shell back in the day, and then after that, Born Again shell is bash. A predecessor to bash would have been KSH, which would have been the Corn shell. And then there are others along the way. There's a C shell, which is an abomination. The Z shell, I think, is a good shell. Has a lot of nice kind of customization features. But how's that decision made?
Some dude liked it, so put it on the kernel and people started using it.
Let's log into, let's see, let me come here. So there's a directory that most of you are familiar with, the etc directory, etc., which, just as a side note, I get people all the time who say things like, go downtown, go to the store, and they do that. It's not ecta, it's etc., etc. So make a mental note, it's etc. All right, sorry. I'm not an English teacher, I should just shut up. All right. So Jaguar has this etc. directory that has just a mishmash of basically a lot of configuration files are in it. One of them, etc password. There you are. So that's your ID. It used to be there was a period of time in the past where that letter X would actually be the crypted password. And they replaced that. If you put a lowercase x, then there's a file called etc shadow, which actually contains those crypted passwords. And now you need to have basically root permissions to get into it. So those have been extracted out of this. These are, that's a user ID, I want to say a group ID. This is, generically speaking, is just called a comment field. Most frequently you have the person's name. What's this in green? The home directory. Absolutely. And what's this one on the end? That's the program that login runs. Doesn't have to be bash. Okay. So all of this stuff can be configured by the administrator.
Can you not run bash? Like, not run anything?
Yeah, let's look at that again. Right here. Let's try that. User sbin no login. So it prints that message. What happens when you end the bash program? Let me end the bash program. What happened? I logged out, yeah? So what it does is it runs whatever that command is, that application as the last entry there, and once that application is done running, you're logged back out. So looking at what I typed here, you would would log you in if you were somehow managed to authenticate as daemon, and then it would just simply say this account is not currently available. That program ends. It's just a single output statement, and you're logged back out. Okay? And so you have that kind of thing for just an additional level of security. You need that daemon user for administrative purposes, but you don't want anyone to have the ability to log in as that user, and so that's a way you can prevent that from happening. So the man pages were mentioned. Let's see. Let's talk a little bit about the man pages. Man, of course, is short for manual. The man command has its own manual page. An interface to the online reference manuals. So the way it used to work back in the old days before Linux was Linux and it was just Unix is that, let me pause and say, the man pages as we see them here as an online manual entry always existed. They always existed online. However, back in the day, you would go to AT&T and pay a license for Unix, and it would be installed on some machine with that license that you have, and included with that license would be an actual physical binder in half size, right? So the binder would be about this big, half the size of a sheet of paper, and you just flip it open, and it had tabs for different sections of the manual, and all of these pages that we're looking at here that you do, man ls, all of these would exist in that binder as well. Okay? Now regarding the sections, if you do a man on man, right here, not very far down, it shows you the different sections. We'll be spending the bulk of our time in section 1 of this manual. If you were to take 540 from me, you would be spending most of your time in section 2 and a little bit in section 3. The distinction is the system calls are those calls that are interacting directly with the Linux operating system. Library calls, for lack of a better term, tend to be a level up, and they end up being things that are not necessarily built intrinsically, not tied intrinsically to the Linux operating system, but are there because they're standardized. A good example would be right, we've all used the rand function. So that would be an example of a standard library function call as differentiated from a system level call. Let's see, let's look at this again. What else do we have? So section 4 covers special files. Section 5 covers file formats. So if you wanted information about etc password, you could find it in section 5. Section 6 is the latest in 1970s text-based game technology, and then the rest of them. Okay.
Doesn't the show have like the first episode of Star Wars or something? I was thinking that.
There's I know someone created an ASCII art. You talking about the ASCII art thing?
Yeah, that basically
you can.
Get to see, like,
Yeah, man, you got to have a lot of time on your hands. Has everyone seen that?
It's in every single computer, though.
Is it?
Yeah.
Like
the original creators did it.
It wouldn't be installed. It could certainly possibly be a package that you would install, but it wouldn't be standard.
It's a netcat thing, right? Netcat. That Dutch website kind of plays.
Right. So yes. So I've seen both YouTube versions of it, and as you say, you can actually connect to a remote website, and by virtue of connecting to it, it's going to feed you these ASCII characters. If you haven't seen it, it's basically the entire Star Wars movie, all in ASCII art, with occasional text, captions. Yeah. All right. So it's good to get familiar with these different section numbers simply because if I type man rand, what this shows here is next to the command is it shows you which section in the manual it is. And it's basically going to start at the manual, and as soon as it finds a match, it'll give you that entry. Well, so this is telling us that rand is a command that we can enter at the shell prompt, but I'm not interested in that one. I'm interested in the rand that we've been using when we're programming in C or C++, the function call rand, which is in section 3. So if you look at what I did up here, is you can specify as an option to the man command the section of the manual that you're interested in searching for that particular command. Okay, so when you have the same names, that's how you get around that.
It's actually to telnet. But it's sort of
Right, and netcat is the successor to telnet.
Yeah.
Yeah. Let's look at the man page for bash. Invocation. Sounds a little bit like some RPG sorcerer thing. All right. So it distinguishes between a login shell and an interactive shell. Again, this is how we start up bash. And I think the most obvious is if you provide --login, it will run bash as a login shell instead of an interactive shell. If you read down a little bit, let me go down a little bit. When you invoke it as an interactive shell, meaning, or excuse me, as an interactive login shell, or as, what am I looking for? Basically, I want to focus on this. If you log in as a login shell, it's going to run commands from etc profile if it exists. After reading that file, it's going to look for this. So many of you have probably tinkered with .bash profile in your home directory. So it's going to run bash profile, and then it's going to look for bash login and .profile. So there are a number of different ones it looks for. It will, as it says here, it's going to look for them in that order. The first one it finds that matches, it's going to go ahead and execute the commands that you have in there. But that's only if it's a login shell. So let's try that. Let me go into my home directory, bash profile. Let me say echo, hi there folks. Let me use printf. I'm trying to break my old school habit of using echo for everything. Why? Because printf has the formatting commands that lets me do fancy things like say, let me come out of here. Printf, quote, %04.4, how about 04D, and I want to print out the number 32. I get it. Let me do it with a new line. So I have a 0 padded field of 4 wide. I'm printing out an integer, which D. It's also what most people use is I. I makes sense for integer. Why D for integer?
I thought a D was digit. Or decimal. Sorry.
Decimal integer. Yeah. So either a D or an I will print out an integer. Anyway, these formatting commands aren't important at the moment, but I prefer printf just because I have more power for printing out things. Echo gets a little bit cheesy when you try to do more complex stuff. So I've put this in my bash profile. Hi there, folks. Let me run bash. Doesn't run. No hi there, folks. But let me exit out of there. Let me add that login option. Okay. I finessed. I didn't read it out loud, but and it doesn't explain it in the man page. But there's the original old school way of invoking a login shell. Way back in the day, there was not a ---- login option, and yet you could invoke bash as a login shell. And the question is, how do you do that? So so I do ps. I've got my 2 bash shells. I'm going to clear the screen. I'll type exit, and I'm back to where I started. All right. First, all right. So I don't want to get hung up on this command too much. It's just saying I'm creating a link to bin ls. Oops, it isn't bin ls, is it? I'm creating a symbolic link from user bin ls to Mickey Mouse. If I do an ls, the ls command's giving me a nice little bit of syntax highlighting. That's probably difficult to read, showing that Mickey Mouse is not a normal file, not an executable file. It is a link, a symbolic link. If I do an ls-l to get a long listing, it even is more useful in saying that Mickey Mouse is actually linked to user bin ls. So that just simply means, hang on, I'm going to change something here, talk about it in a little bit. If I type Mickey Mouse, it's going to run the ls command, right? All right, so nothing too interesting about that other than the fact that you can do it. All right, I did this in 2 steps because I always space out on how to get the hyphen. Well, all I wanted to do, let me do an ls-l. The second entry there is I created another link, -bash, which is going to just run bash. So now I can either type bash and run a shell, or I can type -bash and it'll run a shell, right? Just like typing Mickey Mouse or ls, it's going to run ls. Let me run that. So how's that working? Why? Well, we can start with the obvious. What's the difference between when I ran bash before and when I ran bash this time? The hyphen, yes? So the question is, could you write a program that had different behavior based on the name of the program? The name of the executable. That's what's different, is the name of the executable. How do you do that? Yeah. You can check on argv0. Let's look at, where's my bash shell.cpp. Here we can say if argv sub 0, that's the first one. We're interested in the first character of the first argument, right? So I'll do that. Is equal to, I don't want to use hyphen, let me do uppercase X. I'm gonna put I'll put 3 dots there just so it's easy for us to not get confused when we see that print out. All right, let's try it. G++, bash shell. Whoops. Oh, I'm sorry. Look at that, a little 111 error there. Okay, so doing that is well within our grasp, and that's how it was done. back in the day is what you'd find in etc password would be bin bash with a hyphen. You don't. Let me see if where's vim? So here you have a program in user bin, which is just a link to EX. And EX is just a version of vim that behaves a certain way. Does anyone know what view does instead of vim? If I can say vim bash shell.cpp, I'm in my vim editor. I know we haven't talked about vim for those who are not familiar with it, but if I type view instead of vim,
Make it non-editable.
Non-editable.
right, read only. So here's an example of examining argv sub 0. If argv sub 0 is view, trip the read only flag. Okay, so there's an example of how that's being used even today. Let me remove that. Does anyone? So this gets into a little bit more just command trivia. Anyone know why I have the double hyphen there? What if I didn't?
This is a double hyphen. The directory, I guess. Directory to bin bash.
I'm not sure. I'm not sure I understand. What if I did? Let me do this. So what does that do? Does anyone know what that option does? Huh? Recursive. Yeah. All right. So this is the BASH options. Right. And we don't mean it as options. We mean that the file name starts with a hyphen. So by doing this, that says we have no more options following. I think it may even say that. Let's have a look. No. To remove a file whose name starts with a hyphen, use one of these commands. Yeah, you see, that's clever. I don't know why I never thought of that. But actually, this is what I prefer to do. Huh. All right. So, what is this? What is path?
All the areas that you can draw commands from when you type something into your command line.
All the areas you can draw commands from when you type something in from your command line. Yeah, absolutely. What if we typed, how many shells do I have going here? I have 2 going. That's fine. Then I'll just exit out of this one after I destroy it. So ls path equals nothing, ls vim So if you look at it there near the top of the screen, you can see that it's delimited by colons, and it's just a list of directories where the bash will look for programs to run. Now I can get out of here. All right, so now I'm back to my original, and I've got my path here. So anyone, this is a variable, yeah? Let me create another variable. It's all in uppercase, it doesn't have to be. Meaning it's a variable that is understood and created by the shell, right? This is part of the functionality of bash that the programmer wrote in there. But it doesn't have to be uppercase. I'm gonna go lowercase. What's that going to produce? Oh, okay. See, I fell prey to the old.
It's not the variable.
So it'll print out the literal characters. So in the shell, you do have to precede it with a $sign to say I want the contents of that variable. And there it is, Todd. So actually, what I should do, I wonder if I.
Printf goes to the white space. So it's you encase it in the string.
Yeah. So yeah, let me. Okay, I'll give up for the moment. I'm just going to use echo for this. A little bit schizophrenic when it comes to printing out of the shell. All right, there we go. Echo path. All right, let's run another shell. I'm going to clear the screen since I'm at the bottom here. Let me repeat that. Echo name, echo path. Let me run another one. PS. There's a second one running. Echo path, echo name. So what's interesting about that is that this path variable, when I created another shell, that path variable came down and was part of that new bash shell that's running. So now let me use a couple terms. If you've had OS, I imagine, or certainly my systems programming, the concept of parent and child. And the parent is this very first shell that I got when I logged in. And then this one would be a child of the parent. So the child inherited, if you will, got a copy of the parent's environment. The path is part of the parent's environment, but name is not part of the parent's environment. So since name is not part of the parent's environment, it did not come down to the child. You can, however, make that variable part of the environment. How can I make the, so now I'm back to where I was. How can I make name part of my environment so that children inherit me, if you will? No. Okay, so let me, there's a command you can type, env, which will tell you what your environment is. So all these, so again, them being in uppercase is just by convention. There's nothing magical about them being uppercase. They could have been in camel case or all lowercase or whatever. So don't get hung up that they're all uppercase. These are all variables that are in the environment. Meaning that if I type bash and I create a child, every one of these variables will be in the child. But name didn't go because name isn't listed here. Name isn't in the environment. If I type export, that is the command, export name. That puts it in the environment. Now let me type env again. Yeah, near the bottom there. So now it's part of the environment. Let me create a child shell. Clear the screen, bash. Path is there. Name is there. Okay, so export is what puts it in the environment. Let's talk about it at a programming level. Did you know that you have access to your environment in every one of your programs you've written? So there's argc and argv. Let me pause for just a moment. Will that compile? Yeah, of course it'll compile. Those are just names of input parameters, right? There's nothing built into it. Some people get under the impression that these are somehow built in, but they're not. They're just names, convention. By convention, we call them that. There's a third one. Let's look at some of these. So let's say cout arguments. And then we say for, oops, int I equals 0, I is less than, what is I less than? argc plus plus I. cout argument I equals argv sub I. Let me run that and test it. Okay. Oops, haha. That fooled me. All right. ENVP, note that this for loop was easy to do because I had an argument count. There is no count of arguments here for this variable. The way it works is it's a set of strings, and then there's a null pointer for the final one. So what I have to do is I just loop, and I stop looping once I hit a null pointer. Let me do it the longhand way. So let me say character pointer, whatever, environment pointer equals envp p sub 0, and then I'll create a while loop, and I'll say while env pointer does not equal the null pointer. I'm going to see out. Yeah, I'll just see out env pointer. Let's try that. Ooh. Ooh. Let me see something. What did I do wrong? First of all, I've got...
It's the first position. No. First one would be the one.
Why did that screw up? Where's my bug? All right, let me try what I would have done before, which is oh, of course. No, that isn't. So that has to be. Oh. All right. So let me do it the other way then. Oh, I'm still seg faulting, which means I'm marching past the edge. I print, I add 1, well, it's not equal to the null pointer. I'll investigate why I've got a stupid bug there, but let me come back up here. So here is the loop on the arguments, and then as I loop on envp, you can see that this is envp sub 0, this is envp sub 1, sub 2, sub 3. Everything in your environment you have access to in your main function there through that third argument. All right? So this is how bash works. When you type ls, it looks through envp, finds the path variable. It probably did it up front, right? It isn't doing it every time you type a command. It would have parsed this and created some sort of array where first it's going to look for ls here, and then it's going to look for ls here, and then eventually it'll find it. And if it doesn't find it, what it'll do is it'll say command not found after it looks everywhere in the path. So that's what that's doing. Where does that take us? How about, let me write a simple shell script. That wasn't very slow, was it? I forgot that part. All right. So I'm running this program. What is bash doing? Well, is bash printing out the string? Let me do this. Yeah, my script is, right? So bash is just waiting. Bash is just waiting for this to finish. It doesn't have to wait. The shell has something called job control. I can type Control-Z as in zebra, and it says stopped. Let me actually copy that script. Let me copy slowly.bash to more slowly.bash. You could go either way. Certainly .sh was the original, but
does it have any? Like,
there's no distinction. No. I can type a Control-Z here. Let me do it again. I'll do more slowly again. I can do Control-Z. You'll note that each time it said 1, 2, 3. I can type jobs, and it shows me I have bash is dealing with 3 programs, and I've stopped all 3. I don't have to run it such that I have to wait for it to finish. I can run it in the background so that bash will immediately start talking to me. And if I type jobs to look at these again, I can say BG for background, and I can choose which one I want in the background. I want job 2 in the background. And the % is used to indicate which job you're talking about. Now it's printing counting, but you'll note I have my prompt back, so bash is still interpreting commands. If I type a PS, I got a bunch of stuff going there. Let me actually type jobs. I think I typed jobs. Nope. Jobs. And you can see that it shows that the 2 of the jobs have stopped, one of the jobs is running. What if we type background %1?
The ampersand is what makes it going back.
Right, so doing job control, I can specifically say BG for background or FG for foreground. Let me do jobs. And you can see I've got 2 of them running in the background. And you can see this ampersand here that they use to show that it's running in the background. This one's still stopped. To run it in the foreground, I type FG %3. Or I can choose one of these in the background actually and run it. I can say foreground %1. And now I don't get my prompt back because one of these 2 is running in the foreground and the shell is waiting for it to complete before it gives me another prompt. Right? So that's just a general feature of the shell, is this idea of job control. As was said, how can I kill those? How can I kill job 2? Anyone want to hazard a guess? Kill %2. Jobs. I have one left, kill %3, terminated, and then as was shown when we did jobs and it showed the ampersand there, you can actually do that directly. So I can say more slowly, just put the ampersand, and that immediately is running that job in the background. If I type jobs, it shows that it's running.
Now it's stopped, does that mean it's, can you just leave it at stop? Like I just control Z everything. Is it automatically?
Not after a certain amount of time. That job will stay stopped until you exit bash, and then it will kill it. All right, kill %1. There we go. I think we're about. So, which ls, which sort, which. Let's talk very briefly about what happens when I type ls. This gets into systems programming a little bit. What happens when you run a program at a programmatic level? What is the one command, the one system call, so it's in section 2, what is the one system call that enables all things multi-user, multi-processor in Unix, in Linux? Fork. So fork is what creates I'll leave all that stuff there. Won't use it. Cout. Hello world. Compile that and run it. Oops. Okay, nothing new there, but we put fork in front of it. Now we run it. Whoops. So I do man fork. It is in how do I get it without? It's giving me a different one. So let me type. So there we got 2. 1, 2. So the moment you type fork, you get 2 copies of the program running. That's literally what it does, right? It's exponential. Let me just do that. So here we get 2 of them running, and then for each of those 2, we're gonna fork off another one, so we end up with 4 running. 1, 2, 3, 4. So that's how that works. That's half the battle. Fork gives us an exact copy. Basically, one is the parent, one is the child. So when I type ls, the very first thing that bash does, assuming it finds ls, is it does a fork. So now there are actually 2 bash processes running. And then the next command is a variant of exec. No, that's because it's in 3. So fork's a real easy man page. Right? It's just, that's how you call it. Exec has a bunch of different versions. We don't have to get hung up on it. Basically, what this is showing is we just have to identify the executable on the file system, and it will run it. It'll basically take whatever process you have running and totally replace it with the program in the file system that you specified. So that's what bash is doing when you do ls. It does a fork to get a child copy of the shell, and then it runs exec to replace it with the ls program. Then ls runs, quits, the child dies. Okay. So the reason I ask that is for, we know that's how ls works, that's how cat works, that's how vim works. Which ls, that's where it is. What if I say switch cd? There is no program that anyone wrote for CD. And the great question is, why is that? It is built into Bash. Why is it built in? So Bash, this is the parent. Do a fork. This one then, let's say it was a separate program, replaces run the CD command. When it runs, if it was the same as ls and it was a program that someone wrote, it would do a fork and then it would do an exec CD, right? And then what does CD do? Changes your directory. And so what it would do is it would change the directory of this process. Once it's done changing the directory, then the program's done. And we're back to the parent. And note that the parent never changed directories. It was the child that changed directories. That's why it's not a separate program, because you need to have the parent changing the directory. So what if I type CD and hit enter? What does that do? Takes you to the home. How does the shell know where home is? It was here. Right? These are all, where's Vagrant? Here's the home directory of Vagrant. So this got set up. Anyone know how that got set up? That's part of the environment. Yes, if I type env. Right here. Can we change that? Sure. What about this one? What's PWD? So all these things are being controlled by variables in your environment, and by changing them, then it changes how Bash behaves. All right, so let me cut you loose with a little bit of an assignment. Go ahead and dive into the project's assignments directory. I want you to write a simple shell script. Let me talk about that. Whoops. All right, so the script is just a text file. At this point, I haven't talked about Vim, so anyway you're humanly able to create a text file, go ahead and do that. I want it to be, I'm getting, no, not in any language. It's got to be in the shell. So first, the preamble is that by convention, you want to end the name of the file in a .sh or a .bash. Between you and me, this doesn't matter. It could be anything. You'll know it could be Mickey Mouse or whatever. But I, by custom, make it either .bash or .sh. There's something that goes at the top here. Does anyone know what this line's called? The shebang. In old school Unix parlance, this is bang. This is splat. So that's where this is derived as the shebang. And this is just saying what program you should run to interpret this stuff down here. If you do not put anything, it assumes that it is a script belonging to the shell that you're running, bash script. Later on, we'll see things like user local bin python 3, something like that. Now, the convention is changed a little bit. This is certainly what I grew up with, and I almost invariably do this. However, I believe this is more customary now. I guess I should check that. Yeah. And the reason is that these different shells, historically, some put them in /bin, some put them in /user bin. So if you were to write a script for bin bash, and then you ported it to a different Linux distribution that had bash and user bin, then you break things. And so they kind of standardized by saying, okay, we'll put this thing called env and user bin and kind of standardize that way. So what you have to do is write a shell script. Oh, then the other thing, and we'll talk about this more down the road, but if you haven't done it, for me to create a shell script, let me create a shell script called my shell script.bash. Let me do an ls. Let me do a cd. Let me do an ls. There's my shell script, 3 lines. Okay, if I try to run my shell script, it won't because it's not executable. So we want to change the mode, add execute permissions, and then once I do that, then the execute bit is flipped. Again, if you haven't been exposed to it, we'll talk about it some in the near future. So just use it as a recipe for now. If you're not accustomed to it, create your file, change mode, plus execute permissions, and then I should be able to run it. All right. What you have to do is I've created this tarball that you can grab. It has, as the name implies, lots of files in it. All the files are empty. They're basically just a bunch of file names. It's empty files. I guess I should look at it. So how many are here? Looks like there are about 100 files here. They're all in the lots of files directory. They all have 3 random characters and then 3 digits. Okay? What you have to do is figure out how to do a for loop in bash, and then write a loop to print this message. This is file this one, this is file this one. The reason I'm asking you to research it is this stuff's pretty straightforward. I don't want to lecture on it. Just look it up. You'll have it in a couple minutes. After you do that, test it. Make sure that this is working. Oh, then I want you to open up a couple of them, add a few words in 2 or 3 of the files so that there are contents in 2 or 3 of these 100 files. Then look up the if statement, and then modify your script to only print this message if the file is not empty. So if you added that to 3 of them, then you'd only see this for 3 of the 100 files. Test it, of course. And now the hardest part is you need to write a loop to rename all of the files. So AED 044 should be file 044, AFE 065 is file 065. What you have to do is take the 3 letters, remove them, and put the word file there instead. I provide a hint here. If you go to the man page and you search for remove matching prefix pattern, that'll get you to where you need to be able to solve that. Okay? Everyone got it? All right, go ahead and have at it. I will give as an additional challenge if you finish a little bit early. One thing then you can try to do is, can you write a script to generate 100 files in this format? 3 random characters and then an incrementing serial number. Yes.
Is it 244?
That's a good question. I don't know. Because you don't have your computer, is that correct? Yeah, why don't you go have a look?
Okay.
And if not, let me know, and I guess I don't have any choice but to cut you loose to do it at home. And also on this one, you are welcome to work together. So to the extent you know anyone or are not shy, definitely I encourage you to team up to get this done.